In this video, I will try to provide the general chemistry test questions and answers. Okay. Now, note that the questions are not very clear, so do well to increase your video quality in the settings so you can see the questions clearer. Okay. Also, I'll be trying to read out the questions so that you can also get them better. Let's go to question 1. Question 1 says, which of the following is not an SI base unit? Okay, so which of these is not an SI base unit? The first thing you have there is degree Celsius. Next thing you have there's kilogram. Next thing you have there's electric current. Next thing you have there's luminous intensity. And then you have second. What's the instruction here? They said underline the correct answer. Right? Take note that they said you should underline the correct answer. So they're asking which of the following is not an SI based unit. Of course, electric current is not a unit. The unit is actually amperes. So I'll underline electric current. This is my first one there. But this question actually has two answers because also luminous intensity is still not an SI based unit. All right. Luminous intensity is actually a quantity, and the unit for luminous intensity is actually candela. Right, candela is spelled Candela. All right, so these are the answers. So the first question there has two answers: electric current and luminous intensity. Of course, for degrees Celsius, we can also say either degrees Celsius or Kelvin. That's for temperature. Also for kilogram, kilogram is the unit for mass, and then seconds is the unit for time. All right, so you have two answers for this question. Number 2 says the correct answer for 7.932 cm plus 5.3 cm plus 8.4 cm in the correct significant figure is. Alright, so I'll try to zoom this a bit. Alright, is, so let's take down the values there. 7.932, so I have this as 7.932 plus, next thing you have there is 5.31, so you have 5.31 plus, the next thing you have there is 8.4, so you have 8.4. Alright, let's combine this. If I'm to sum this, I'm having 7.932 plus 5.31 plus 8.4. Your answer is actually equal to 21.642. That's your answer. All right. But if you look at what you're given here, they said in the correct significant figure, which is this one here, right? In the correct significant figure. Now, what exactly do they mean by the correct significant figure? Now, here's how this is done. All you have to do is from the given numbers, take out the smallest significant figure. For instance, for the first number here, 7.932, you have 1, 2, 3, 4. So the first number has about 4 significant figure. The second number you have 5, 3, and 1. And that's about 3 numbers there. So this is 3 significant figure. The last number you have 8.4, and you have 2 numbers there, 8 and then 4. That becomes 2 significant figure. So what you should notice is that for questions like this, all you have to do is to take out or to use the significant figure of the least or the smallest significant figure from the numbers given, which in this case is 2 significant figure. All right, from the given numbers there, the least significant figure is 2 significant figure. So that means I will approximate this to 2 significant figure. All right, so my first significant figure there is 2. The next term there is 1. Of course, if I look at the term close to it, is 6. 6 is a plus 1. So 1 plus 1 gives you 2. So that becomes 22 as your answer. So your answer should be 22. Looking at the options here, you have 22 as your third one there. But this one comes with a 3 zeros, you can see here. Meanwhile, the 22 at the extreme, this one here, comes with just 22. So I'll take the one at the extreme. Alright, so the answer becomes 22. So you should know that this is how to tackle this question. Okay, if they say you should use the correct significant figure, so what you just have to do is all you have to do is to just take the significant figure of the least significant figure from your given terms. Alright, so that's how you do this. Let's look at the next question there. Question 3 says Rutherford's experiment bombarded metal foil with For this question here, the answer is alpha particles. All right. So I'm going to underline alpha particles. So the answer there is alpha particles. So take note of this. All right. You have X-ray particles, gamma particles, beta particles, alpha particles, neutrons. The answer there is alpha particles. Question 4 here says, use the figures below to answer question 4 to 6. Which of the following figures represents A? Number 4 says a pure element. All right. So please ignore these answers here. Which of them represents a pure element? Now, if you look at from what you're given here at the top, you have atom A and atom B. All right. See, atom A is this, that's just white, while atom B is shaded. If it's a pure element, it means that element is not mixed with anything. And that means this one here is supposed to be 4. So number 4, this is, I'll write 4 here. This is number 4 because you can see it's just white here and white here and white here. It's not mixed, so it becomes a pure element. Also, if you look at which one again? The last one here. This last one here, I can still write 4 here. These elements, although not the same, but they are still pure because this is just black, it's not combined. This is just white, it's not combined. This is just black, not combined, and also just white, not combined. So you have these two things for number 4. All right. So we've got number 4, a pure element. The other ones are combined. If you look at them, the next thing there is a pure compound. That's number 5. Right? A pure compound. For something to be considered a compound, you must have at least 2 atoms combining. So where do I have 2 atoms of the same element combining? That's at this part here, this first one here. So I'll call this 5. So this one here is my correct answer. Let me call it 5. Right? So you can see that I have 2 dots, like 2 black, the first black like this, and then the second black here. So basically you have 2 atoms combining to give you a compound. So it becomes a compound. This one here is not a pure compound. I think that's basically what you have there, a pure compound. Also, if I look at this one here, if you look at this particular diagram here, this is still a pure compound because the compound is made up of the 3 compounds here in this particular figure here, this one underlined. They are made up of exactly the same kind of element in the same proportion. So you can see 1 black and 1 white creating the compound for all of them. So we can say it's a pure compound because the compound is made up of exactly the same kind of elements in the same ratio. So we can call this number 5 too. So this is another number 5. Number 6, we won't call it a pure compound because if you look at this one here, okay, if you look at this one here, we can't call this one here a pure compound. Reason being because you have the first compound having 1 black and another black. That's for this one here. And then you now have this one containing a black and a white. So they are literally 2 different things. So we can't call it a pure compound. Next thing we have is number 6 here, says a mixture of an element and a compound. All right, so if you look at this one here, this one represents that. So you can see an element, 1 black, that's 1 dot, one dark there. Then you have a compound of dark and white. So we can take this one here as 6. So this is 6. All right, so you have this. All right, so basically we can call this one here 5. We can call this 4. We can call this 6. We can call this 5. We can also call the extreme one 4. So where do we put this one here? This is not a pure compound, neither is it a mixture of an element or a compound. So there's nothing for this. So this should have been left blank. All right, the next one here. The next one, question 7 says, the p subshell contains dash orbitals. All right, so please note that p subshell contains, contains 3 orbitals. All right. So the answer is 3. That's your answer for this. So you underline the one having 3. Okay, that's your answer. Next up, number 8 says, to which sub-level do all orbitals belong? Right. Number 8 says, to which sub-level do all these orbitals belong? So what you have here actually belongs to the p orbital. Right. So this is what a p orbital looks like. So the answer there is actually p orbital. Now let me just emphasize something on this. When it comes to orbital diagrams, note that if you have this, I'll just give you a rough sketch of this. So let's say I have this and this. For the s orbital is usually circular in shape. So if you have something like this that is circular in shape, this is what the s orbital usually looks like. Where you have z here, you have x, and let's say you have something going this way, this one here would give you a Y. So this is what the s orbital looks like. So you could note this just for another year. Okay, then what you have here in this diagram is actually your p orbital. All right, then the last one, then your z orbital, it looks like this. So you have z orbital looking this way. It's similar to the p, but then it's different in the sense that if you have z here, you have x here, and let's say you have y this way here, you have y this way. Okay, so if you're having something that looks like, for the z orbital, let's call this z orbital, you'd have it as basically this. Right, it looks like this, and then you could now have something looking like this one here, which is this. All right, so you can see what the z orbital looks like, and this is just one of it. Right, there are about 3 of these z orbitals, but what to note is that you have this thing looking like twice of this, 2 of this one here 1, and then this one here 2. In total you have about 4. That's 1, 2, 3, and 4. That's what distinguishes the z orbital. Why in the p orbital you have just 2, 1 and then 2. All right, so just take note of this. That's how we solve this question. So the answer is p orbital. Number 9 says degenerate orbitals they are simply orbitals that have the same or equivalent energy levels. So the answer here becomes equivalent in energy. Right? They have the same or equivalent energy level. So the answer here is equivalent in energy. That's your answer. Number 10 says electromagnetic spectrum does not include. All right, which of them does it not include? Now, before I tell you the answer there, let me tell you what the spectrum includes. All right. Now, note the electromagnetic spectrum includes number 1, gamma rays; number 2, X rays; number 3, UV rays; number 4, visible light; number 5, infrared; number 6, microwaves; and number 7, radio waves. So if you look at that, the correct option here, the one that is not included, would be what there? Water waves. So water waves becomes the answer. It's not there. All right, so the answer is water waves. All right, let's look at the next one there. Question 11. Why does an atom have no net charge? All right, why does an atom have no net charge? Let me illustrate that using this. So look at this one here. Let me tell you why an atom has no net charge. You have this one here. So this is my first. Let's call this an atom here. If this atom has, let's say, 1, 2, 3, 1, 2. This atom from here, you see that positive will cancel negative, positive cancels negative. This atom becomes positively charged. For a positively charged atom, we have more number of positive charges, which are protons, right? More protons, and then less electrons, negatively charged. So a positive charged atom is an atom that has more protons than electrons. Again, if I do this, I have 2 protons, that's 2 positive, and then 3 negative or 3 electrons. Again, if this cancels out, positive cancels negative, positive cancels negative. Observe I have just 1 negative left. All right, so this atom becomes negatively charged. So for a negatively charged atom, we have more negatives or more electrons than protons. That's the concept. What if they are equal? If they are equal here, positive cancels negative, positive cancels negative, positive cancels negative. So observe that everything is cancelled here and it becomes neutral. Now, for an atom to be neutral does not mean it does not contain protons and electrons. No. For a neutral atom, we have equal number of protons and electrons, such that the number of electrons being negative cancels the number of protons available. All right. So let's see which option rhymes with this. Looking at this here, the first one says positively charged protons cancels out the negatively charged neutrons. Neutrons are not negatively charged, so you have to be careful with this. Next thing there says, each subatomic particles carry no electrical charge. No, they carry charge, just that the charges are equal. Both electrons and protons are equal in number. Next one says the positively charged neutrons cancel. No, neutrons are not positively charged. They are neutral, so that can be the answer. Next one says the negatively charged electrons cancels out the positively charged neutrons. No, Neutrons are not positively charged. That can be the answer. The fifth one says the negatively charged electrons cancels out the positively charged protons, and that's correct. All right. The negatively charged electrons cancels out the positively charged protons. Yeah. So that's your answer. All right. The next one here, the last one for page 1, just says what is the volume of benzene left unreacted when 10 cm cube of benzene is treated with 45 cm cube of oxygen based on the reaction. Now for the reaction here, we have 2 of benzene, that's 2C6H6, combining with, we have 9 moles of oxygen, so 9 moles of oxygen to give us what's available there, 6 moles of carbon dioxide, 6CO2 plus, what else do we have there? 6H2O, that's 6 of water, H2O. Now, normally, if you look at this equation here, observe that the equation is not even balanced. It's not a balanced equation because for carbon, 2 times 6 gives you 12. So we have 12 atoms of carbon on the left hand side. For the right hand side, we have 6 times 1 here, which gives us 6. So the equation is not even a balanced equation. But then the emphasis says based on the reaction. All right. So we're not even supposed to even balance this equation. No, we're supposed to use what is available or what was given. All right, so that's what you should note here. Then they said, what's the volume of benzene left unreacted? Okay, let's get a molar ratio. For this, the coefficient here is 2. So I have 2 is to, for this we have 9. 9 is to, we have 6 for this, and that becomes 6. And then finally we have 6 for this, so that becomes 6. All right. Now this is molar ratio, yes, but then we can call it the molar ratio or volume ratio. All right. It's called either the molar or the volume ratio. So this could serve as either the number of moles or the volume. That's in cm cube, as you can see here. Now, in this question here, note that our attention were drawn to 2 things specifically. The first one being benzene, and then the second one being oxygen. I think this was oxygen here, right? O, X, Y, then Gn. All right, so I'm going to take out benzene, which is C6H6, and then I also take out oxygen, which is what there? O2. All right, if you take their molar ratio there or their volume ratio, for benzene I have 2, and then for oxygen I have 9. You can see that's there. So this is 2 for benzene, 9 for oxygen. Now this is 1. Also, if you look at it, said you have 10 cm cube of benzene treated with 45 cm cube of benzene. 10 cm cube of benzene treated with 45 cm cube of oxygen. Now here's what to do. They said, what is the volume of benzene left unreacted? So we'll call the benzene X, all right, since we don't know. All right, so we'll call this X. Now I'm calling benzene X because they specifically asked us to find the volume of benzene left unreacted. So we assume we don't know it, right? And then for oxygen, they said 45 cm of oxygen. So I'll come here and call this 45. Let's do the simple math here. Of course, what I have to do here is to cross multiply. So it becomes 9 times x, it becomes 9x is equal to, you now have 2 times 45. 2 times 45 is about 90. To get x, I'll divide it by 9, divide it by 9. This cancels this. X is equal to 90 divided by 9 gives you 10 cm cube. That means we need about 10 cm cube of benzene to react with 45 cm cube of oxygen. Coming back to the question again, they said, what is the volume of benzene left unreacted when 10 cm cube of benzene? Now hang on. In an actual sense or from our calculation, we need about 10 cm cube of benzene to react with 45 cm cube of oxygen. Now in the question, they said they gave us an actual 10 cm cube. So the question now becomes, if I need 10 cm cube of benzene to react with oxygen and I'm having 10 cm cube, if I use up the 10 cm cube, what will be left? Nothing will be left. That's why it becomes 0. All right, because I needed 10 cm cube of benzene to react with the 45 cm cube of oxygen, and all I've got is the same 10 cm cube. So in essence, nothing will be left. All right, I'll use up all 10 cm cube. So the answer becomes 0 cm cube. So your answer here You underline this one here, 0 cm3. That's your answer. Alright, so this is for the page 1. Let's go to page 2 of this question. Alright, so before we go to the part 2, if you enjoyed this video, please do well to hit the like button. Alright, like this video, leave a comment. For the comment, tell us if you're enjoying this video. If you have a question, leave it in the comment section and I'll attend to your question. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do well to subscribe and hit the bell icon so that you get notified whenever we upload a new content. Then finally, do well to share this video to your friends so that they can also learn. Don't forget to check out my website www.jonahemmanuel.com/courses, or you can also check the book section at www.jonahemmanuel.com/books. Register an account to the website and then proceed to get any of the available courses or books. Alright, so I'll see you in the part 2.